Welcome to the first lesson on the logic design of our application, or building the logic. So we're going to set up the data access in this video. And the reason why we're going to do data access first is because I want to have that foundation set before I start looking at the logic for a form. Otherwise, what happens is the first time I design a form, I'm going to also have to design my data access logic. And that means I'm doing two things at once, and it gets a little confusing. So this way, I'm able to do one at a time and spend a little more time and get a little more thought process to how I set up my data access. Now, with that said, I will probably add more things to the data access, or I might change how data access works down the road if I find there's a bug, or if I find I want to set up a little bit different. But this will give me a good first start. And also, I'm going to be using the same logic that I've used in previous applications. So I'm taking a lot of the knowledge I've had previously and bringing it into this application. So not really starting from scratch in this. Okay, so let's start off. Let's actually close out everything. And we will pin the Solution Explorer. And in the build time library, I'm going to add a folder. And let's call this data access. That way I can separate my things out into different categories, just like I did with the controls up here. Okay, so I'm going to put in here a class, and let's call this class the SQLite data access. Now I will probably create an interface for this so that I could in the future change out SQLite for something else, but for now I'll leave it. I'll create my class first, and then maybe create an interface off of it. Okay, so with my data access, I'm going to want a few things. One of them is I need to access the connection string, but it doesn't seem like I should put the connection string information in this SQLite data access, because accessing the connection string is the same no matter where you go. So let's actually add that somewhere else. And so I'm going to create a new class, and I'll call this data access helpers. And then we got public static. Okay. And then inside here, I'm going to create one static method. Now I'm going to make this an internal method. And the reason why, let's just create it first and I'll show you why. So internal static load connection string. And I'll pass in an ID, which is the connection string name. And by default, I'll have the value as default. And then we need to actually add, we'll get to it in a minute. So anyways, internal. The reason I use internal is because I want this to be available to any class in the build time library. Any class in here. So that way the SQLite data access can access it. If I later add a SQL data access, that could access it as well. However, outside of the build time library, this essentially is private. So that's what internal does. It's public inside this library. It's private outside of it. Okay? So let's also add a reference. And we need a reference to the system. Wow, can't type today. System.configuration. Okay? That's a .NET DLL, but it's not checked by default. It's not brought in by default. And now we can say return configuration manager. We hit control dot here and add a using statement for system.configuration. So configuration manager dot connection strings will pass in that ID and say give us the connection string, which is a string. Okay, so that returns a string. And by the way, we can say static string. There we go. Now it's all good. internal static string load connection string. I was trying to think of too many things at once when I was talking. So internal means it's only available as a public reference, essentially, but only available inside of this assembly, this DLL, this build time library. It is not available outside the build time library. Static, meaning we don't have to instantiate this class, not that we can because it's a static class, but we don't have to instantiate it in order to access this. And the reason why you don't have to is because we're not storing data in this class. We're just calling methods that do something and return back a different value. So in this case, we are loading the connection string and returning the, in this case, default connection by default. Now, for us, that should be all we need because app.config, we call this default. So we'll return that by default, okay? So now in our SQLite data access, we can access the connection string. So let's start by creating a load and a save method. Now, typically when we call a load method, let's create one right away. So let's, you know what I'm going to do? I'm going to have just this SQLite data access for now, but I'm not going to create an interface for it, I don't think. And the reason why is because I think that if I go down the road of creating another data access, instead of replicating what I do here, I think I'll make it even more generic and allow it to be used by anything. So it's not just one or the other. So I'm going to go ahead and just say, for right now, it's SQLite data access, and eventually it will be data access for anything if we need it to be. So, but for right, and this is one of those things that as you develop something, you have to be careful. There's a tipping point here. And the tipping point is how detailed and how future thinking do you want to be versus how much do you want to write code right now? Because I can spool create a public method, and this is going to be a load data method. Now, I'm going to have it be static and list of t load data t. Okay? And so what this will do is it's going to say we need to load data, and it's going to be a generic method. So whatever model you pass in, it's going to return a list of that model. I'll explain that in just a minute. So name. And the default is going to be default. All right, so that's my method. Now it's quite long, and there's some confusing things in here, so let's deal with this now. All right, so what I'm going to do is when I do a dapper command and I say connection.query, I pass in a model. And that model says, okay, when we get the data back, put this into a list of that type model. Well, if I were to lock myself in to a specific model, then I have to create this code over and over and over again for every load data call that I want. Whereas if I make it generic, I can eliminate some of that repeated code. So let's do that. So I'm going to say, all right, I'm going to say dynamic parameters. And hit Control dot and say using Dapper. So this is a Dapper type. Okay, and normally we create this list in order to pass in a set of parameters that we pass into our query. Usually I try for store procedures, but in SQLite, those aren't really a thing. And so we're going to do just SQL commands, but still I'll have my items as parameters. That way there's not an injection capability, or less of an injection capability. You want to avoid injection attacks on SQL because that's a really dangerous thing. So dynamic parameters P equals new dynamic parameters. This is what Dapper is going to expect for our list of parameters. But I'm passing it in as a dictionary of type string object. So I need to convert that over to dynamic parameters. Now, there's a couple ways I could do this. What I could do is I could do some link statement that converts it over. Or what I could do is I could do a for each. So let me demonstrate both of these. That way you can see the differences and which one you kind of like better. So the for each is really easy. So for each var, we can call it param in parameters. And then we'd say p.add param.key param.val or value. So what it does is it takes the key value pairs, which are string and object types, and it adds the key as the first value and the value as the second value. So what this would be essentially, we're passing in key values like this. So the key would be something like at first name, and the value would be Tim, like so. Okay, so that's the key and the value. Now, if you're not familiar with dictionary, essentially what dictionary does is this first item is called the key, and that key cannot be repeated, meaning we can't have two at first name values as the key. Okay, so that way, since it's unique, then we can look up items based upon their key. So if I said, give me a parameter that has the first name as the key, you would say the value is Tim. Okay. Now what we're using it for is just basically a paired list. Okay. So you have this pair of information we want. We're not going to do both. Okay, so I'm going to comment this out just to be clear. Option 2 would be to say parameters.toList, because list has some extra stuff on it. For example, it has for each. And I can say x equals greater than, and then say p.add x.key, x.value. Okay? And this line right here is the equivalent of these lines right here. Now the difference is I had to convert my dictionary over to a list in order to get this for each. Okay, so that is a little bit extra conversion, but it's a nice little link statement that just says, okay, for each one of those, the variable is going to be x. Now what x is one entry in the dictionary. Okay, now one entry has both the key and the value attached to it. So I can say p, which is our dynamic parameters, dot add the key, so x.key, and x.value. So these are functionally the same. Okay, they end up with the same result. It's just which one makes more sense to you, which one's easier for you to do. It's up to you. Now what I'm going to do is I'm going to leave this one in place. It makes sense to me. I think it works, and it's pretty clean. So we do a for each here and basically convert this parameters list over to our dynamic parameters list. Okay, now that we have that done, we can start actually connecting to our database. So if you've done Dapper before, which if you've watched any of my videos, you probably have seen Dapper before, because this is my go-to connection method for any database. And the reason why is because just straight up ADO.NET, which is a valid way of connecting to a database, is cumbersome. Okay, you're dealing with data tables and all these different things and trying to convert it and make sure you're doing casting and boxing, and it's a little bit of a mess. And it takes a lot of work to get right, but it's fast. It's very fast. Now, the other end of the spectrum is Entity Framework. An Entity Framework, it seems a little magical, because what it does is it says, okay, you just connect to this table, and it says, well, here's an object now. And if you just say load this object, it will load it up from the database. And it just kind of works, which is great. The downside is a couple things. First of all, it adds a lot of code to your project, and it's black box code. It's code that unless you really spend the time, you don't really understand what's going on. And it calls an awful lot of things internal to Microsoft's DLLs to actually make it work. And so if anything goes wrong, and I've seen it go wrong, if anything goes wrong, it's a bit of a mess trying to figure out how to resolve it. Now, it's so much of a kind of a beast when it comes to what it can do that there's whole books written about it, which in some ways feels like a good thing, because it feels like, well, great, they have some great documentation. And there's some great people out there that do a lot with Entity Framework. But if you have to have great people doing blog posts and books and other things that try and teach you how to use your data access, maybe it's a little complicated. Okay, so that's one thing. And two, Entity Framework is slow. Okay, by comparison, Dapper is an order of magnitude faster than Entity Framework, which that's a big deal when dealing with customers, especially if you're dealing with any kind of data set size at all. You want to have a fast, responsive data access. And third, when it comes to security of your database, Entity Framework isn't very friendly. It does not do a good job at allowing you to secure your SQL database or other database. So those are my reasons for not using Entity Framework, and also for not using ADO.NET, but instead for using Dapper. Dapper fits in the middle. It's very, very fast. It's usually 3 or 4% slower than direct ADO, which isn't bad compared to what it's all doing. Because when I make a request, I get back a list of my model type, not data tables and all the rest. I don't have to do the mapping. It's done for me automatically. So it's really worth that 3 to 4%. Okay, so we set up our using statement, and we say using IDB connection. Hit Control Dot to add the using statement for system.data. And we say, I usually call it CNN for connection, equals new. And this is going to be a SQLite data access. Okay, SQLite. If you're familiar with connecting to SQL, that's usually SQL connection. But in this case, it's a SQLite connection. Oops, SQLite connection, not SQLite database. So it's Control Dot, and we need to add the using statement. Okay, SQLite connection, and then we need to load our connection string. So we have our helper, so data access helpers dot load connection string, and we'll pass in our DB name. And actually we'll call this here. var is not the equivalent of var in JavaScript. var in JavaScript means basically it's a variable, but it can be anything it wants to be. That's not what we're doing here. Instead, we're saying this is a type that will specify when we actually create it. Okay? So we have to specify it immediately. We can say cnn.query. Now, normally we pass in our model here, but I'm going to pass in my model t. I'm going to explain the generics once I create everything. But essentially, this is whatever model you pass in. Okay? And now I'm going to say, what's my command, which is my SQL statement, and then I need my parameters, which is p. Okay? So that will now connect to SQLite and execute this command and return a series or an IEnumerable of this type, whatever it is. Now, I prefer to have a list to work with. So I'm going to say return rows.toList. And now I'm returning a list of t. Okay? So what this generic method is, and this is something you might want to put in your personal library. Okay? What this generic method is I can pass in a model. So let's just say I pass in person model. And in fact, let's document this a little bit. I'm going to say, if I passed in a person model, so I'm going to say load data person model. Let's just pretend we have a person model. And it's got, let's say, first name, last name, and email address properties. Okay? And then I say the SQL statement is select star from people or person. That's the table. Okay? And then my parameters are going to be, let's just say nothing. Okay? We could pass in parameters, we're not going to. So what this will do is this will return a list of type person model. And that will be however many people were found when I did a select star from person. Okay? So that's what it's going to do. The beauty of this is that now I don't have to do all of this code. In fact, I don't even have to know about Dapper. So that's one of the things I did with this dictionary string object is normally you'd have to know about dynamic parameters in order to create that list. But I don't now. I just pass in a dictionary of type string object, which everybody has access to, and then it gets converted to a dynamic parameters list. Now, there are some limitations to this method. One of the limitations is that dynamic parameters can do so much more than just passing in a key and a value. It can have output parameters, and it can do the typing of parameters. So it's I would say just as simple, but this may not be simple to you. So it's very, very similar at least. So public static, and this would be a void because we're not actually returning anything. We're just saving data. And I'll call this save data. And I don't have to be of type T because I don't have to know what the types are that I'm passing in. Instead, what I'll do which, if you notice, this looks pretty much identical to this. All right, because it really is. All right, and now we're going to create our using statement, which is going to look just like this. So let's go ahead and copy and paste that. And now we have cnn.execute. We have our SQL statement. And we have our parameters, which we haven't created yet. So I need to create those. Well, I can actually just copy and paste this too. Okay, and we're done. Now, I really could have made this one method and then, somehow worked out the duplication here. Anytime you can copy and paste, especially in more than one area, you might want to look at, hey, is there a better way of doing this? But I think this is pretty unique. I mean, we do have a little bit of duplication here. I could probably create a separate method for this, but I think what I'll end up doing when I do that is I'll create more methods, but not create any more clarity or any more reuse. So I think I'm going to keep it separate because that way it's very, very clear what's happening. And there's only, in this case, 5 lines of code. In this case, 6 lines of code. Nope, still 5. So 4 lines of code here and 5 lines of code here that are actually doing anything. Okay, not the curly braces. So that's not a lot of code, which that in itself is not an indication of whether or not it's a good method, but it's a good indicator. And it also, you might want to think about, do I want to make this more complicated in order to make it, in theory, simpler? Okay? So there's a balance here. And I'm trying to hit that balance by saying, you know what? Yes, this right here could be a method, and maybe I make it a method, but I think instead I won't. I'm kind of debating that. I do like the idea of not having to do this twice because of the fact that if I decide to change this logic, I have to change it twice. So I'm actually kind of talking myself into another method. So here's what I'll do. Let's actually make this class static. That way, since we're not saving data in here, we can make it static, but that way I can create an extension method. So public, let's make it actually private. Private static. This will return a dynamic parameters. And we're going to call this method to dynamic So what it's going to do, let's just, right here, I'll copy, I'll paste. You know what? I'm going to rename that to P to list for each. There we go. So now I've created a my dynamic parameters, which actually, no, I have not. Because I'm saying p.add, and that's not what I want. I want dynamic parameters output equals new dynamic parameters, and then output.add. There we go. And then finally, return output. Okay, so what this does is it takes in the dictionary of type to a dynamic parameters list. Okay, so that's what this does, is attaches it to this element and then passes that element in as P. So then I create this dynamic parameters variable called output, and then for every item, or for the dynamic parameters, for the dictionary, I convert that to list, and then for each of those, I add it to the output. So I have an X val, an X key, and then I return output, which is a dynamic parameters. Yes, it's a little more complicated, but what that allows me to do is, instead of having these two lines of code, I just say parameters dot to dynamic parameters. That's it. So now that places. So that's a helpful little extension method. It's going to make my life a little bit easier, and it allows for a little less repetition in how I do things. So that internal debate, which actually was external, I was talking to you, but that debate I had over whether or not to create a separate method for this was really important, because by having that and not just ignoring it and kind of talking it through, I realized that if I ever changed that logic, I'd have to change it in two places. And that for me is a red flag, because even though it's only a few lines of code, the fact that I have to change logic in two places means I'm opening myself up for bugs. Because what will happen is I'll change it in one place and not realize that same logic is somewhere else. And then And now I have my load data method and my save data method. Now this is private, so you won't see this extension method outside here because I don't want them to. I want just the load data and save data to be available. Now the reason I made this class static is that if I didn't have the class static, then this would have a problem, because this is not an extension method that will work. An extension method has to be in a class that is static. So therefore, if I do this, then I can have the extension method forms, knowing that we can actually get data for them and put data back in the database when we so desire. Okay? So that's it for this lesson. Make sure you understand this. If you have any questions about how this works, what I'd recommend is you create a separate project, put this code in there, and then just try it out. Don't try it out in this program, because you don't want to create test code that you then later delete and miss parts of. So just make sure you're always testing in a separate test project versus your actual, what I'd call a production project. Okay? So try these things out. Make sure you understand how it works. Make sure you understand what this does and how it works and how the internal works versus public and private. Okay? All right, once you've done that, then move on to the next lesson.